I'm Mark Cavanaugh for Cavi Coaches, and today I'm going to coach you up on drawing acceleration time graphs and determining the sign on acceleration from a velocity time graph or a position time graph. So determining acceleration time graphs is not only important just for sketching the graphs, but it's important for determining the sign on acceleration, especially when we get into forces. So let's recap the motion again. Not moving, constant velocity in the negative and positive direction, speeding up in the negative and positive direction, and slowing down in the negative and positive direction. So there's 7 types of motion as we've talked about in the previous 2 videos. So here's an important point. In an algebra-based physics course, AP Physics 1 or 2, or an honors level, it is generally assumed that the acceleration is constant. So what does that mean? For purposes of graphing, that means that acceleration time graphs, if you are drawing them, will only be horizontal lines. It doesn't mean that you're not going to be given an acceleration time graph that is a sloped line or a curve. It just means when you draw them, they're always going to be horizontal lines. So for the 7 descriptions of motion, what that means is there are only going to be 3 graphs, and these graphs can represent multiple types of motion or different types of the 7 types of motion we've discussed. So let's look at constant speed first of all. So let's first talk about how we can determine acceleration. It can be determined 2 ways, and this is the sign on acceleration. The slope of a velocity time graph can help us determine the sign and the value of the acceleration, and the concavity of the position time graph can help us figure out the sign on acceleration. We're going to talk about the concavity a little bit later on in the video. For now, we're going to focus on the slope of a velocity time graph. So let's look at our several ways where we have a constant velocity. Not moving is a constant velocity, constant speed positive direction, and constant speed negative direction. So if we look at these graphs, all 3 of them have a slope of 0 because they're horizontal lines, which means that the acceleration is also 0. So when we graph the acceleration, we sketch the line on the axis. This represents a 0 acceleration. Now this means that it doesn't tell me anything if it's moving or not. It tells me that the speed or the velocity is constant, that a horizontal line, 0 slope, no acceleration. So it's either not moving or it's moving at a constant speed. So let's talk about how we can determine the sign on acceleration from a description of motion. It's important, like I mentioned before, to determine the sign because the sign on acceleration is going to tell us a lot about what we need moving forward. So one thing that I use is determining the sign thinking of multiplication of integers. So let's treat the positive direction as a positive integer, the negative direction as a negative integer, speeding up as a positive integer, and slowing down as a negative integer. So we can look at the combination of those. Let's start with an object speeds up in the positive direction. It's like multiplying 2 positive integers, and that is going to give us a positive acceleration. If we look at an object speeding up in the negative direction, it's like multiplying a positive and a negative integer together, and that gives us a negative acceleration. We have an object slowing down in the positive direction. This is like taking a negative times a positive, and that is going to give us a negative acceleration as well. Now, what about an object slowing down in the negative direction? What that means is that we're going to have negative times a negative, and that gives us a positive acceleration. And as you can see, just by saying positive acceleration, that doesn't tell us if it's speeding up or slowing down. It doesn't tell us the direction that it's traveling. What it tells us is the combination of the speed and direction. So it is important to describe the motion of an object using both speed and direction and not the word acceleration, because a positive acceleration can mean either, and same with negative acceleration. So let's start first by looking at the graphs for acceleration time for positive acceleration. So let's start with our velocity time graphs. So we have a velocity time graph from our previous video, where this shows that it's speeding up in the positive direction. It's speeding up because it's getting further from 0 and it's drawn on the positive side. The second graph, drawn on the negative side and getting closer to 0, shows that the object is slowing down in the negative direction. So if we look at both of those lines, both of them have positive slopes. So with the slopes being positive, that means the acceleration is also positive. So it means when we draw the graph, we're going to have a horizontal line because the slope doesn't change for our velocity time graphs, and it's horizontal line in the positive side of the time axis because the acceleration is positive. So let's look at what this means for a negative acceleration. So remember, negative acceleration doesn't describe motion. So we can look at our velocity time graph. We have a velocity time graph that shows slowing down in the positive direction and one that shows speeding up in the negative direction. And what do these two graphs have in common? Well, they both have a negative slope, but one's positive direction motion and one's negative direction motion. So the slopes both being negative means that the acceleration is negative. And it's constant because the slope of the velocity time graph does not change. So we draw a horizontal line below the time axis to correspond to a negative acceleration. Again, it does not describe the motion, it just tells us what's going on with the acceleration. So let's summarize the acceleration time graphs. So here we have a zero acceleration, and zero acceleration meant three types of motion that we've discussed: not moving, a constant speed in the positive direction, and a constant speed in the negative direction. And we have a positive acceleration, which represented two types of motion: speeding up in the positive direction and slowing down in the negative direction. Remember, it's like multiplying integers. Speeding up positive direction gives us a positive acceleration. Two negatives also gives us a positive acceleration. So we cannot describe motion from just the description of acceleration. So here's a negative acceleration, which could be speeding up in the negative direction or slowing down in the positive direction. Both of those being opposite signs, so multiplying opposite integers gives you a negative acceleration. So let's look at what the concavity of a position time graph, how that tells us the sign on acceleration. So first off, what is the concavity? Well, that just tells us which way the curve is opening. If the curve opens upward, then the acceleration is positive. If the curve opens downward, then the acceleration is negative. If the position time graph is linear, that means there's no curve, which means there's no acceleration. So if we look at a position time graph, we can see that the position changes from 6 to 0 over 3 seconds, but it's a straight line graph, which means that there's no curve, which means no acceleration in this situation. So if we look at these two curves, we can see the concavity. If we continue that curve, the curves are concave upward. So that means they're opening upward towards the top of the page. This tells us that we have a positive acceleration. These two curves, we can see, are concave downward. They're opening down towards the bottom of the page, which means that they show a negative acceleration. So here's how you can check your graphs with position time and velocity time and acceleration time. So let's look at a more complicated combination of motion. So you can see the first half of this graph from 0 to 5 seconds shows a concave up graph, which means we have a positive acceleration. The second half from 5 to 10 seconds shows the concave down, which shows that we have a negative acceleration. So a positive acceleration means that on a velocity time graph, we should have a positive slope, and concave down means we have a negative acceleration, which means on a velocity time graph, we should have a negative slope. So if we draw the corresponding velocity time graph, we can see, looking at the tangent lines, that they're sloped negatively throughout the whole trip. So the first part is negative and decreasing steepness, and after the 5 seconds is negative and increasing steepness. So negative and decreasing steepness means that it's slowing down in the negative direction, so the velocity time graph should get closer to 0 before 5 seconds and be drawn below for negative. And then after should be getting further from 0, but also still on the negative side because the velocity is negative. So when we draw the corresponding acceleration time graph, we know from the concavity opening upward, we should have a positive acceleration. We also have a positive slope on the velocity time graph. And the acceleration time graph from 5 to 10 seconds is negative because the slope is negative, and the concavity of the position time graph is negative. So this is how you can determine sign on acceleration time graphs and drawing acceleration time graphs. I hope this was helpful. I hope you have a great day and an even better tomorrow.
you found this video helpful, don't forget to click the like button down below and subscribe to my channel, Cabby Coaches, and follow me on Instagram and Twitter at Cabby Coaches.